Hey guys, Cody here with Advanced Power Quality. Today I wanted to finalize our segment on storm preparations. Today I'll be talking to our industrial customers out there. Prior we did a little segment for residential customers. Now this is going to be a two-part segment just because there is a lot of items I want to talk about for our industrial customers out there. So let's go ahead and jump into it. The first thing that I want our industrial customers out there to think of is, how long can I be without power? Is it a day? Do you have generator backup? Is it, a few cycles, momentary outage, as we discussed earlier, breaker, recloser operations, those cause, second delay outages. So whenever a customer is thinking of these items, a lot of customers have generator backups. Well, customers need to realize that the generator ramp up time is about 8 to 10 seconds normally. So that 8 to 10 seconds may kick off a lot of their equipment. A lot of equipment can't ride through 10 seconds of no power. Only thing may be that long is really large industrial motors with that rotating inertia. And again, 10 seconds is asking a lot of your equipment to ride through that event. Some customers go with ATSs, automatic transfer switches. Now, one thing you need to realize, this is still about a 1 second transfer period, which is still 60 cycles. That's an eternity for electrical equipment. And one other thing I want to discuss about ATSs, so what it is, you'll have the utility here, you'll have your substation. Out of the substation, you'll have multiple feeders. Say this is our customer. These are laterals coming off of the feeder. Customer's not on. But their preferred feed is our red feeder here. Their backup feed is the black feeder. And you have your normally open point here, typically identified by NO. So what happens is power goes out on red feed, it switches to black feed, but that's a 1 second delay. So like I said earlier, that's a long time for electrical equipment. Now they do sell such things called static switches. They can get down to 1 to 2 cycle transfer period, and most all your equipment is going to ride through these type of events, but they are very, very expensive, typically upwards of $1 million. One thing discussing this, so utilities, whenever a utility, you talk to them about ATSs, they plan accordingly to have capacity to switch over at any time. Typical utility system planning, you should know, you shouldn't have a feeder loaded up higher than about 20 to 40%. This allows your normally open points for the capacity for black feeder to pick up red feeder. Now it's a little bit more complicated than that. You have typically 8 to 10 feeders coming out of a substation, depending on how rural of an area you are. And there's, tons of normally open points all over, connecting different feeders and such. Even feeders going to different substations with normally open points in the middle. Now, why I say 20 to 40% is because this allows black feeder here to pick up the entire load of red feed here. Now, I've seen some utilities push back their planning cost and upgrade cost and capacity cost so far that they've, under normal conditions, operate their feeders and their load at 90%. That allows them no switching capabilities under outages, big events, even work scenarios. I actually was working with a utility about a year ago where they overlooked their protection scheme, and what breakers have is a fault current recognition. It's a minimum current. So what happens is current reaches that value and the breaker recognizes it as fault current. Well, their load on that breaker reached that capability, and the breaker operated about, I want to say it was 23 times in a 1 hour period, but they were so delayed. It has about a 2 minute restart if the breaker doesn't recount each time. So it never went into lockout. The customers on that feeder saw 23 operations. Now that's torture on any equipment. There were some pretty upset customers due to that event, but make sure you talk to your utility about this matter. Make sure they have capacity for switching and such as that. And again, this is a feature that APQ can do for you. We'll work with your utility. We'll work out all the bugs and make sure that your ATS is good to go. One other thing is talk to your utility prior to storm season and see if they'll do a patrol on your line. Go ahead and get ahead of any issues. Do any tree trimming, animal mitigation, any concerns, but give them a month or two to actually do the work. And try to get to them before storm season hits, as storm season is always their crazy season. Most of the time too busy to take care of anything else. Before storm season hits, know where your obligation starts and stops. So most of our industrial customers, they're going to be on pad mount transformers. So this isn't really too much of a scenario, but knowing, I guess, if it's your underground wire or not from the pad mount. But for our overhead customers, knowing if the utility obligation stops at the transformer, the weather head, the top side of the meter, the lift pole, for possible tree trimming concerns. A lot of times high winds, especially in our southern states and Florida, we'll see a customer didn't know that his obligation for tree trimming stopped at the transformer lift pole. Tree falls on the line, he's in there waiting for the utility to come fix it, and the utility's already been out there and established, customer needs to get this trimmed up. They'll open the door and leave it to the customer. So know that ahead of time, that way you can jump on it and get service back as soon as possible. But like I said earlier, guys, this is going to be a two-part series. I didn't want to go too lengthy into detail in one series, but feel free to tune in to our next segment, and we'll explain some more details in what to do in the aftermath of the hurricane. Some concerns that a lot of our customers probably don't think of. Thanks, guys.